Hello students, how are you? Doing well? Very good. Dear students, we have been learning very important organic chemistry chapters. Today we are going to learn chemical reactions which undergoes these compounds, aldehydes and ketones. Reduction of it is very important students. Most of the times specific reagents are there, that what I am going to explain. Reduction of aldehydes and ketones. So the simple reducing agents are, it may be aldehyde or ketone students. So the reagents, please write down. The reagents usually we come across is sodium borohydride or lithium aluminum hydride or palladium on carbon hydrogenation. Yes, so the cheapest reagent what we can use for the reduction of these ketones to alcohols. Aldehydes gives alcohols, primary alcohols, ketones gives secondary alcohols. This is OH and hydrogen. Yes, so reduction, what is reduction? Just now what I said, LiAlH. They again stick on to LiAlH. So lending of electrons is oxidation, or gaining of electrons is reduction, or addition of oxane is oxidation, and here addition of hydrogen is reduction. So stick on to this reduction step. We are adding hydrogen, H2 we are adding to the ketone or aldehyde to give this alcohol. Yes, sodium borohydride, lithium aluminum hydride in presence of palladium carbon hydrogen. So here question comes. So is it, can I use sodium borohydride or lithium aluminum hydride for the reduction of these two? Yes. So it is not specific. However, this sodium borohydride is cheap. You can use this cheap reducing agent. Compared to lithium aluminum hydride is costly. At the same time, it is highly pyrophoric. Care must be taken while handling this aluminum hydride. And palladium carbon is very costly reagent, and it is has to be done under extreme care conditions. So the easiest method for the reduction of sodium borohydride is of ketones and aldehydes is use of sodium borohydride. Yes students, next. So there are two name reactions which are given to you, that is Clemmensen reduction where you will use acid catalyst or in acidic medium zinc amalgam in presence of HCl. Let us see aldehyde or ketone. Yes, in presence of zinc and amalgamated zinc. So this is amalgamation will be done to activate zinc. Amalgamated or copper couple also you will get, right? Usually zinc, amalgamated zinc in presence of HCl, you are going to get reduction compound where hydrogen is going to be added to this to get this. So this carbonyl compound, it is going to take up H plus ions to form and now the carbocation which is going to be formed is going to take up zinc 2 electrons, transfer of 2 electrons, and this zinc is going to be out as 2 plus to give R negative and OH. And this takes up proton to form carbon and R and OH. Now what is left over? H plus ions. This oxygen takes up R R OH H, and this is positive. It is going to lose this carbocation, takes up zinc, another molecule of zinc, -2 plus to give carbanion. Thus that carbanion takes up proton to give this reduced alkane. The key thing is, the key factor is this: it is acidic medium. So acidic medium, if the compound is having ketol group, just now what I said, ethylene glycol ketol group, this ketol group is going to be cleaved. So this ketol group also is going to be cleaved, and this carbyl compound is also going to be reduced to hydrocarbon, or 2 hydrogens will be added to this. So the compound which is having acid LiAlH group. Yes, students. So please concentrate this type of key points. When the compound is having acid LiAlH group, that compound is not useful in Clemmensen reduction reaction. Right? So Clemmensen reduction is not useful for the compounds which are having acid LiAlH groups. Next, Wolff Kishner reduction. In Clemmensen reduction, we have used acid. So to overcome that acid LiAlH group cleavage, Wolff Kishner reduction. Dear students, don't worry. This is specific chapter what I am teaching for the people, those who are preparing for JEE and NEET. Right? So another videos are going to be made, and there are a number of videos are there in Venus Academy for the people, those who are preparing for CSIR NET, GATE or BARC and IIT JAM. So in that I am going to give number of examples in a different way. And if I teach in that way, it takes each reaction, it takes 1 hour. That what I said. So Clemmensen reduction already I have kept in Venus Academy. Please go through that. You will get number of examples under Clemmensen reduction. So Wolff Kishner reduction. So Wolff Kishner reduction, whether it is aldehyde or ketone, in presence of hydrogen hydrate, what I am going to get? When I treat it with ketone or aldehyde with hydrogen, I am going to get hydrazone. This hydrazone, it can be isolated. This hydrazone, when I do treat it with KOH, base, hydrolysis and heating, I am going to get this alkene. Yes, students. So, for example, I have, this is the compound, acetophenone to ethyl benzene. I can do with this reagent. Yes, students. Let me write the mechanism. So up to here, no question, no doubt. So these hydrogens are acidic enough to taken up by base. So OH, it takes a proton from this nitrogen to form minus, nitrogen minus, this nitrogen minus comes here, carbon minus, this is N, double bond N and hydrogen. So this, at this stage, another molecule of KOH takes up this proton to form nitrogen minus, and before that it takes a proton to give carbon, nitrogen and nitrogen, it is minus. Already one hydrogen is here. When it comes here, and this bond is going to be, yes, it is going to taken up by this carbon to give carbanion, plus nitrogen goes out, carbanion, this carbanion takes up proton which is there in the reaction mixture to give this alkane. Yes, so Wolff Kishner reduction is a base catalyzed reaction, Clemmensen reduction is a acid catalyzed reaction, and both the products are same. Starting materials and products are same, but the reagents are different. Because of that reagent differences, each reaction, Clemmensen reduction and Wolff Kishner reduction is having different roles. Yes, don't worry. So this is how you can do Wolff Kishner reduction. Next. Thank you students. Thank you for watching this video. Please subscribe my channel Venus Academy if you are not yet subscribed, and don't forget to click on like button and bell button. We will meet again with carboxylic acids. Till then, bye, sayonara, all the best, arigato gozaimasu. Bye students.